In this video, I'll discuss Peano curve is not space filling. In 1890, Joseph Peano defined the curve that can provide a continuous mapping between the points in the 1D unit interval and the points in the 2D unit square. Peano curve PC is the first space filling curve, meaning that a curve contains the entire unit square, and supported the Cantor's earlier counterintuitive result that the unit interval has the same cardinality as the unit square. Peano defined PC in a purely analytic way in terms of the base 3 number representation and mirroring operator without reference to geometrical considerations, in accordance with his antigeometrical attitude to analysis. Peano considered x and y, representing the points in the unit square, as continuous function of the parameter z in the unit interval by applying a mirroring operator. He expressed x and y and z in the base 3 number system. As you see here, the key is you can have one-to-one correspondence between z and x and y by this complicated operator. He assumed that every point in the square and line is covered because the digit length of x, y, and z is infinite. However, irrational numbers cannot be expressed in digit representation, as discussed in video 9. Therefore, Peano's proof is flawed because the assumption required for the proof is flawed. A geometric interpretation of PC was presented by E.H. Moore in 1899, which appeared as a paper in 1900. It starts by dividing the unit square into 9 subsquares with a diagonal line as in the figure. The second and successive iterations further subdivides each subsquare into 9 subsquares with diagonal lines. Then the line fills the square as the limit, so that this space filling curve became another proof that the number of points in real number line is equal to the number of points in a plane. However, we can demonstrate that this geometric interpretation of PC is not space filling. If PC is to fill the space, every point in the plane has to be in the curve. Suppose a horizontal line in red across the intersection in figure. Then the zx of the intersection is x is an element in the unit interval where x multiplied by 3 powered by I is an element in natural numbers. In order for PC to fill the space, all numbers in the red horizontal line have to be within x, but there are numbers that cannot be elements in this set x. 1 over 4 is not a multiple of any power of 1 over 3, thus cannot be an element of x. Likewise, a number y, which is 1 over n, where n is a coprime to 3, is not an element of x. And irrational numbers cannot be an element of x. Suppose n is an irrational number, so that it is not p over q for any p and q in natural numbers. Assume that n is an element of x. Then n multiplied by 3 powered by I is a natural number. Then n equals p over 3 powered by I for some p. As 3 powered by I is a natural number, it contradicts the assumption that n is not p over q for any p and q in natural numbers. Thus, irrational numbers cannot be an element of X. Thus, there has to be some, in fact, infinitely many numbers that cannot be an element of X, meaning that there are some points in the horizontal line that are not in PC. This reasoning rejects that PC is space filling. In fact, it is obvious if you compare Cantor set and Peano curve PC. The open intervals between the intersections in each step in generating PC is larger than the open intervals in each step in generating Cantor set. In Cantor set, there are uncountably many internal points, and therefore there has to be uncountably many numbers that are not at the intersection in PC, meaning PC is not space filling. And we have a corollary that C is larger than 3 powered by irrational. The number of points in the red line is larger than the number of intersections because there are uncountably many numbers that are not at the intersection in PC. The number of points in the red line is C, and the number of intersections is 3 powered by irrational. Thus, C is larger than 3 powered by irrational. This geometric proof is equivalent to analytic proof. The set X is a set of numbers expressed in base 3 number system. Thus, the proof that geometric interpretation is not space filling is equivalent to the analytic proof that we cannot complete the bijection in digits between the square and the line because irrational numbers cannot be expressed by digit representation in the base 3 number system. Please send critical comments to this address. Thank you very much.